Welcome to section 1.7, day 1, inverse relations and functions. Today's objectives: use the horizontal line test to determine if a function has an inverse. And then we want to find inverse functions algebraically and graphically. First thing, horizontal line test. A function f has an inverse function, f inverse. We read it was f to the negative first. If and only if each horizontal line intersects the graph of the function in at most one point. In this graph, we do pass the horizontal line test. If you are given a graph and you're asked if it has an inverse, you have to first make sure it's a function. So make sure it passes the vertical line test. And then define if it has an inverse, make sure it passes the horizontal line test. They both must pass, both the vertical and the horizontal line test. Make sure it's a function. Functions that have inverses are called one-to-one because each x and each y can only happen one time. We cannot have any repeat x values or y values. Later on, you're going to see that sometimes we have to restrict the domain of a function so we can find its inverse. Quite often with trig functions we'll do this. We'll also do it with other functions where we want to be able to just take an inverse of part of the function. We will restrict the domain. So here it says, does the function have an inverse? Well, we look at the graph. This is a quadratic function on the left, but it does not pass the horizontal line test, so no. And doesn't pass, and this is how you have to justify. And you can abbreviate HL, just make sure you remember what H stands for. And there you go. The function on the right, it is a function to pass the vertical line test, and this one will also pass the horizontal line test, and you would say that, yes, passes horizontal line test. And this one, if you ever hear it, is also referred to as one-to-one. So that's one thing we have to do is be able to pull a graph up, look at it, and say if it has an inverse or not. Then we want to find an inverse function. So you've done this before. First, make sure it's a function. So you have to do the vertical and horizontal line test to make sure you can, first you have a function and that you can take the inverse. Then in the equation for f of x, replace f of x with y and interchange the x and the y's. So you're going to change all your x variables to y's and all your y variables to x's. We solve for y, and then at the end we replace the y with the f inverse of x. This lets everybody know that we are dealing with an inverse function, and it tells everybody that it is a one-to-one, has an inverse, and we got it from another function. And then we want to state any restrictions for the domain of the f inverse and show that the domain of f is equal to the range of f inverse and vice versa. And you'll see what this means as we go through the slides. So it says, determine whether f of x equals 1 over 2x minus 1 has an inverse. So you can graph it to make sure it has an inverse, and this one does have an inverse. Now it says find the inverse. So we have f of x equals, we want to change this into an equation. So y equals 1 over 2x minus 1. Then we're going to interchange our x's and y's. So we have x equals 1 over 2y minus 1. Then we're going to solve for y. So I'm going to multiply both sides by 2y minus 1. We need to get the y into a numerator. So we have 2y minus 1 times x equals 1, because this cancels. Distribute, you get 2xy minus x equals 1. Get the y by itself, so 2xy. Add x to both sides equals 1 plus x. Then divide out the x, you get y equals 1 plus x over 2x. All right, so we have our inverse. We can break this up if we wanted to, but we can leave it as is. So f inverse of x is 1 plus x over 2x. And you will sometimes see this written. We're going to split it up. We have f inverse of x equals 1 over 2x. So if you have a plus sign in the numerator and just one term, we can break this into two fractions. And this gives you plus 1/2. You'll see it written either way. All right, that is fine in the f inverse. Now we want to look at the domains and ranges. So the domain of f of x. The domain and the range. The domain of f of x. What makes the denominator go to 0? That is excluded. And if you set that equal to 0, 2x minus 1 equals 0, you will find that x cannot equal 1/2. So our domain is negative infinity to 1/2, union 1/2 to infinity. The range. What can our range values be? If you guys remember, the parent function is 1 over x, and our range includes everything except for 0. There's my domain and range. Now let's do f inverse. What does f inverse have in it for our domain and our range? Well, if you look at our inverse function, what can the x not equal? X cannot equal 0. Everything else is included. So our domain for this one is negative infinity to 0, union 0 to infinity. And the range, we have shifted this function up by 1/2. So our horizontal asymptote is at 1/2. So everything is included except for 1/2. And there we can see now that the domain here on the top function is the same as the range of our inverse function. And we do the same thing with the range of our parent, our initial function, and the domain of our inverse function are the same. And you think about it, we're switching the x's and the y's, we're changing the domains and ranges, and this shows you that this is working, that we did do an inverse, because the domain of the original is the range of the inverse and vice versa. Let's do another one of these. Determine whether f of x equals 2 times the square root of x minus 1 has an inverse. If it does, find the inverse. And then we'll do that domain and range part again. This is a square root function. We've moved it to the right one. It is 1 to 1, so we have an inverse. And so we start our process. We have f of x equals 2 square root of x minus 1. Change f of x to y. From here, we are going to do our switch, so interchange the x and the y's, and now we solve for y. To solve for y, square both sides. Y minus 1 is in parentheses. We want to get y by itself, so divide by 4. Add 1 to both sides. And I'm going to rewrite this so it's y equals x squared over 4 plus 1. Last step, change the y to the inverse. To let everybody know that we are dealing with an inverse. So you'll notice that when we started this with our parent function, I shouldn't say parent function, but our initial function, so you should notice with our initial function, we have a restricted domain. So f of x, domain is restricted because we can't let this go to negative. The square root cannot go to negative. So if we set that x minus 1 equal to 0 or greater than or equal to 0, we would find that x has to be 1 or higher. So our domain for f function is bracket 1 to infinity. And our range, we did not shift this up or down, is from 0 to infinity. Now looking at the f inverse function, this is where it can be sort of strange. You have to be careful. Well, in the inverse function, we have an x squared. Well, the x squared doesn't restrict anything. But we have to look at the domain of what we started with. And we started with a restricted domain, so that means our range in our new function is also restricted. Because when we do this, we're interchanging our x's and our y's. So if you actually graph these, I'm just going to put a little sketch in the back corner here. So here's our sketch. So let's do the f of x in red. So initially, if you did this, you'd have 0 go to 0. I should say 1 go to 0. And if we do some nice numbers, because we're doing square roots, 4, if we put 5 in here, 5 minus 1 is 4. Square root of 4 is 2. So 5 goes to 4, which is up here. If you put in 2, 2 minus 1, you get square root of 1. So 2 goes to 2. So this is my initial function. Let's do inverse function. Well, the domain, if you actually graph the whole thing, you would have this graph. Let me do it right. Here we go, 0 goes to 1. It would look like this. It's a quadratic. But if you do this, and you graph this whole thing, it's no longer 1 to 1. It's not, you can't find the inverse of x squared over 4. So we can't use the part that would cause it to have repeated y's. This part cannot be included. Because we have a restricted domain on our original function, we're going to have to restrict things on our inverse function. To keep this thing as 1 to 1, our domain is from 0 to infinity, and our range is from 1 to infinity. And again, if you look at this, our domain is the same as our range. The domain of our initial is the same as our range of our inverse, and vice versa again. But you have to be careful when you make these inverses, when you look at your domains and ranges. If we have a restricted domain in the initial function, be careful with your domain in the inverse function. All right, here we have determine whether f of x has an inverse. And if you graph this, it does have an inverse. And it says define the inverse. Show the domain of f of x equals range of f inverse of x. So again, we do y equals x plus 2 over x minus 3. Interchange your variables. You get y plus 2 over y minus 3. Do some algebra. Multiply both sides by y minus 3. Y minus 3 times x equals y plus 2. Distribute. Xy minus 3x equals y plus 2. Get the y's on one side, x is on the other. So we're going to subtract y, we're going to add 3x to both sides. So we have x, y minus y equals 3x plus 2. Factor out a y, we get x minus 1 equals 3x plus 2. And then we're going to divide both sides by x minus 1. So we have y equals 3x plus 2 over x minus 1. Put in our inverse notation, and we have our inverse. Now we need to do our domain and range. So f of x. What's my domain? What's my range? The domain, we cannot have x equal to 3 for a domain of our initial function. So we have negative infinity to 3 union 3 to infinity. Again, if we put in 3, our domain, our denominator goes to 0. We can't divide by 0. So for our range, we have, if you look at a graph, we have negative infinity to 1 union 1 to infinity. For our inverse function, we'll do our domain and our range. Well, the domain for this one now, for inverse, is we can't be 1. So negative infinity to 1 union 1 to infinity, because 1 would make the denominator go to 0. For the range, you'll see that, again, if you need to look at a graph, you see that negative infinity. We have a horizontal asymptote at 3. Remember, you do your limits. As you go to infinity, you'll find this. And we go to 3, and 3 is a horizontal asymptote, so it is excluded. So our range is from negative infinity to 3, union 3 to infinity. And if you look at them, you will see that they match, like they're supposed to. The domain of f of x is the same as the range of f inverse x, and vice versa. This is how you show it. All right, finding inverses graphically. This is actually pretty simple, I think. There's different ways to approach it. I think the easiest way to do it is to find points on your graph that you're given and interchange your x and y's and then graph your new points. There's another way to do this, but I think this is the easiest way. So if you look at this, we're looking for points on here. We have a point here we can use. We have another point here we can use, and a point here. So give me the points you're using. We are at -2, -7 is a point. We have 0, -3 is a point. And we have 2, 1 is a point. And all we're going to do is, like we do in the equation, we're going to interchange x and y. This is -7, -2. That's our new point. This is -3, 0. And this is 1, 2. And we plot our new points. -7 goes to -2. -3 goes to 0. And 1 goes to 2. And then we try to use the same shape that we had in our original. Try to make sure we have the same shape, and we have a shape like this. And this is my inverted function. Again, if you're using a graph, give me the points you're using, show me your inverted points, and we are good to go. From the table, same idea. When you do your table, try to go from the lowest to the highest for your x values. So we do, this is f of x, this is f inverse of x. Invert or change your x and y's, interchange them. Like I said, I'm going to go from left to right for my x values. This is my lowest x value, so -7 goes to 0. And then -5 goes to -2, -2 goes to -4, 1 goes to -6, and 4 goes to -8. And there is my f inverse in a table. That is all for section 1.7 day 1. Today we're doing inverses of functions. Make sure when you do an inverse of a function that it passes that it's a function by passing the vertical line test, and then it passes the horizontal line test to be able to do an inverse. Remember that when we do an inverse, we have functions that are said to be 1 to 1. Thank you for watching, and have a nice day.